and welcome back to 3.1 Podcast. In our last podcast, we were running out of time as we were talking about error and percent error, so I want to clean that up before we move on to significant figures in measurements. What we were talking about was the difference between error and percent error, and the fact that the actual error could be relatively large, but when you compare it to the measured values, it might be very small. We said that if you measured the speed of light to be 299,690,000 meters per second, when the actual value is 299,790,000 meters per second, you have an error of 1 million meters per second. So you're off by a whole million meters per second. But is that a large error? Well, not when you consider that the actual value is 300 million meters per second. Your percent error is the absolute value of your error, which in our case, our error was in the negative. I didn't put the negative sign in there, but it's actually a negative value because we underestimated the value of the speed of light. So when we take the absolute value of 1 million, the negative 1 million, it's going to be a positive. When you divide that by the accepted value times 100%, throw that in there. I said that it was less than 1% because we were running out of time. The actual amount is 0.3% error. So you are having a very small percent error compared to the actual error. Generally speaking, it's the percent error that we're concerned about. When you're making atomic measurements, you might only be off by a millimeter. But if you are off by a millimeter when measuring an atom, you are off by a tremendous amount. In fact, atoms and molecules are not even measured in millimeters. They're measured by much smaller values. The point is, we generally are looking at the percent error because the percent error puts it into perspective as to the actual measurements that we're making. So we'll be using percent error more than anything else. And in fact, we'll be revisiting that a lot more in the next course. All right, so I just wanted to clean that up. So let's move on to the next topic, which is significant figures in measurements. Some people call them sig figs for short. Let's keep scrolling down here. These are sig figs. Some people call them sig digs, as in significant digits. I'm going to scroll up just a smidge here. There we go. Okay, so here's the deal. When you're taking a measurement, you have to read all the increments and estimate the last digit. All right. So here's a ruler. Here's a block of wood. First of all, there's your block of wood. Then here's your ruler. But the ruler doesn't have any increments or lines on there that tell you any measurement. We just know that the entire ruler is 1 meter to this point right here. So when you measure this, you know that you're somewhere between 0 and 1 meter. But you don't know exactly where that is, so you have to estimate that digit. You know you're less than 1, but you're greater than 0, so you know it's going to be 0 point something. Well, if you were to eyeball this, you would say that somewhere in here is the halfway point. You don't know exactly where it is, but that's a pretty good guess. You know that it's slightly more than that halfway point. It could be, and I would say that right about here is halfway between this, what our guess is 0.5, and our 1 here. So I'm going to say that this is slightly less, or slightly more than 0.5. The book even, and the notes even call it 0.6. Some people might call it 0.7. They don't know exactly how much bigger that it is than the halfway point. That's where error comes in. When we deal with error in measurement, we're not dealing with the fact that we did it wrong. We're not dealing with the fact that we did the calculation wrong, or we wrote down a wrong number. Real error deals with the fact that the last digit that we write down is an estimation because we run out of lines. Now, there are more accurate instruments than others. And if we take the same block of wood, let me scroll down a little bit, and measure it compared to this ruler that has more markings on it. This is the exact same block of wood, the exact same ruler. This is 1. Down here is your 0 mark. This says 10, 20, 30, 40, 50, 60. But really, when you're dealing with meters, these 10, 20, 30, 40, 50, 60 are dealing with centimeters. You'd actually put a decimal in front of these if you were still talking about meters, which we want to. So we'll go ahead and do that. right now. Okay, so now, because we have a more accurate ruler, we know that it is greater than 0.6, but less than 0.7. So 0.6 is accurate, because we know that it's going to be 0.6 something. But again, we don't know what that last digit is. You have to estimate it. Well, it is just above 0.6, so we might call this 0.61 or 0.62. The book calls it 0.61 meters. Let me put a meters up here. But some people might call that 0.62. Probably not going to call it 0.63, because if this is the halfway point between 0.6 and 0.7, this right here would be the halfway point, which would be 0.625. I could see someone calling it 0.62, but definitely not 0.63. But again, that's where our error is coming into play. So we're going to guess this is going to be 0.61 or 0.62 meters. And again, number and unit. And finally, if we scroll down to a more accurate ruler yet, notice now, here's our 0.60, here's our 0.61. This ruler is slightly below 0.61. Well, how far below is it? Well, that's getting very, very tight. Our book is calling it we know that it's 0.60 something because it's less than 0.61. The book is going to be calling it 0.67 meters, but I could easily see someone calling this 0.606 or 0.608. Again, that's where the error in measurement comes into play. So you have three measurements of the exact same block using three different rulers. They give us slightly different measurements. They're not all completely wrong. They just have different levels of accuracy. This is only accurate to the tenths place, this is accurate to the hundredths, and this is read to the thousandths place. But you always read every digit and then guess one more digit beyond that. Alright, let's take a look at a couple more samples, because the same trend follows no matter what you're measuring. Let's measure some volume now. Okay. This isn't labeled. We'll call this A, B, and C. And this first one, we're measuring a liquid in a graduated cylinder. Here is 50 milliliters. You can't see it on here, but this is actually measured in milliliters. Here is 60, and each line is going to be 1 milliliter. That's going to be, we have 51, 2, 3, 4, 5, the long line, 6, 7, 8, 9, and then you're up to 60. Now, when you read a liquid, you read it to the bottom of the meniscus. And so, if you can see, here's 51, 52, and 53. I can see the bottom part of the meniscus. If you look over here, you always read to the bottom portion right there. It definitely is above 52, but it's slightly less than 53. So I know that this is going to be 52 point something milliliters. It looks to me that it's above the halfway point, and it actually looks like it's very, very close to that 53. So I'm going to call this 52 point, I'm going to say that it's 8. Somebody could easily call it 52.9, but again, that's where the error comes in. Now notice you're reading upwards in this case, because here's 50 down here, 60 is up here, so you have to read up. Now other instruments you actually read down. An instrument called a burette that we'll be using periodically is actually read downward, because here is 23, and then as you go down is 24. So for letter B, as you read down, let's take a look at where we're at here. It looks like each line is going to be a tenth of a milliliter. We have 23.1, 23.2, 0.3, 0.4, 0.5, 0.6, 7, 8, 0.9, and then finally you have 24. So each line is a tenth of a milliliter. The line is somewhere between 23.4 and 23.5. So we know it's going to be 23.4 something. And so it looks like it's right in between the two, so we're going to call this 23.45 milliliters. Notice that it's not 24.55. You are not reading this up, you're reading it down. Okay? In the next podcast, because we're running out of time here, we'll go ahead and tackle letter C and then talk about the Atlantic Pacific rule.